Okay, so this is the first lesson of this unit, 2.1, Introduction to Functions, and I would definitely encourage you to use the guided notes for this lesson just because there are some problems that are difficult to write out on loose leaf. So this whole unit is going to be on exploring functions, learning about functions, playing with functions, all that kind of stuff. So before we deep dive into that, this lesson is to really learn what exactly is a function. So a function is a rule that assigns one output, which we also call the y, for every input, which we call the x. And so again, there's one output for every input. And generally, especially when we're talking about science, input is what we call the independent variable. So we call it the independent variable. We also call it the domain. Domain is all the possible x values. And the output, we often call in science the dependent variable. And, in math, we often call it the range. The range is the possible y values. So functions can be represented in mappings, ordered pairs, and graphs, okay? So just to repeat, there has to be only one output for every input, okay? So this whole lesson is going to be on how can we determine if something is a function. So the first type of thing that we're going to look at is mappings. These are what we call mappings, okay? So the mappings tell us that, hey, the 1 goes to B, the 2 goes to B, the 3 goes to C, and the 4 goes to D, okay? So again, in order for something to be a function, every input can only have one output. So if we notice, the 1 is only going to one place. The 2 is going to one place. The 3 is going to one place, and the 4 is going to one place. So this is a function because each x value maps to only one y value, right? And if you notice, it can map to the same y value, okay? That's fine. This is okay, right? Now, if we look at this second example, right? If we start from the bottom, the 3 maps to 30. The 4 maps to 40. But then the 2, it can map to either 20 or 40. This is a problem, right? So the 2 is the problem because it's mapping to multiple places. So this is not a function because the input 2, the input of 2 maps to 2 different outputs, okay? So again, every input can only go to one output, right? So you can't have things like this. This is not good. That makes it not a function, okay? Another way that sometimes we see functions or inputs or outputs is coordinate points, right? And if you remember, a coordinate point is x comma y, right? And so x is the input, y is the output. So what you have to look for is, okay, so this question is saying which set of ordered pairs represents a function. So you want to make sure that every x value is only going to one y value. So if you want, what I like to do is I actually like to write it out as mappings, right? So I'm going to write out my x and y. So I have 6, 3, I have -1, 1, I have -9, -5, and then -9, -1, right? And if I write out the mappings, the 6 goes to 3, the negative 1 goes to 1. But if you notice, the negative 9 can either be negative 5 or it can be negative 1. So this right here is a problem. The fact that negative 9 has two different outputs, that is a problem. So this is not a function, right? Because negative 9 has two different outputs. So similar, if we look at the second one, okay, 1 is 2, negative 9 is 9. If we notice, these both have negative 9s, right? So this is a problem again because negative 9 shouldn't be going to two different outputs, right? So this is, again, also not a function, right? If we look over here, we have negative 2 and negative 2 twice going to 0 and 4. Again, this is not okay, right? So I'm going to write it here, not a function, because negative 2 can't have two y values, right? So this is not a function. If we look here, okay, we have 8, negative 5, 2, 2, negative 2, 2, and 3, 6. So this actually works out because every x value has its own y value, right? So again, that's okay. The last way that we look at inputs and outputs is with graphs, right? So to test if something is a function, we use the vertical line test. If the line cuts once, it's a function. If the line cuts more than once, so I'm just going to write 2 plus times, it's not a function, right? So what this test says, we call it the vertical line test. So if I were to draw a vertical line, like in relationship A, let's say I draw a vertical line here, you can see that it crosses the graph in two places. If I draw it here, again, it crosses in two places, right? If it crosses more than once, this is not a function. Versus in relationship B, if you notice, no matter where I draw a vertical line, it's only hitting once, right? It never cuts through twice. So this is a function, okay? So this is a function because it only cuts through once, okay? So now you should be able to determine whether something is a function, whether it's graphs, coordinate points, or mapping. Move on to the practice.